Okay.
Is that the letter N?
That is the letter N.
Okay.
So this is not quite a geometric series, right? This is a finite geometric series or a truncated geometric series. I'd probably tend to call this a finite geometric sum. I would kind of reserve the word series for things that are infinite. So, what else? At any rate, I have a whole bunch of these things I want to add up. Does anybody know what the real world application of such an object is? My claim is probably each and every one of you will deal with the real world application of this at some point in your life.
Money?
Specifically with a certain kind of money.
Anything with like an interest rate? Maybe? Like,
Yeah, kind of things with interest rate. This is how an annuity works. I know most of you don't ever intend to have an annuity in your lives.
What is an annuity?
An annuity is how a car loan is structured. It's also how a mortgage is structured. It's also how college savings plans are structured. Or retirement plans. So, my claim would be if you intend to borrow large sums of money or save large sums of money, you're going to want to know about this at least a little bit. Cool? So, let me just see if I can calculate the sum of such an object quick. So, I have so far S is A plus AR plus AR squared all the way up to A to the N. Or sorry, AR to the N. So what was our trick for the infinite one?
Multiply by r.
I multiplied by r. So I'm going to do that same thing. I'm going to take this, I'm going to multiply by r. I'm going to get rs is
AR.
Oh, yep. AR plus AR squared plus kind of continuing onwards, right? And all of these kind of shifted down a spot.
What about the infinite?
And then what about the last one?
It's going to be
AR
A
to
to A.
the N plus 1.
No.
There will be someplace down here, one that thing got shifted over a spot, right? That'll be ARN plus 1. This is why I show the infinite one first, because we don't have to worry about the last term. Because now we're going to do the same thing we did before. We're going to take this whole thing,
Multiply it.
multiply by -1, and then add, or just subtract.
Cancel.
And then some things are going to cancel. ARs are going to cancel. AR squareds are going to cancel.
Doesn't it end have there's like a +1 and an exponent which doesn't cancel out.
Yeah, that AR to the N plus 1 doesn't have anything to cancel against it. Does the AR to the N?
That cancels it.
Yeah, that one's got something to cancel against. So in the end here, I get S minus RS is
A plus
so close, buddy.
AR.
A minus
Oh yeah, yeah.
A times R to the N plus 1.
Why minus? Oh, subtract.
Yep, because I was subtracting all that
Understand.
stuff, right?
So what about the N on the top? That just canceled out.
Yeah, that one dropped off because there was here a ARN minus 1, right? That became a AR to the N. You guys see that? Like all of those had a chance to cancel. But that one last one didn't exist in the first thing. So that was new. So when I go to subtract, all the others have a partner, right? They all had something before them, except for that last one.
Okay.
You guys see that? Okay. So, solve it. So,
Damn.
Solving for S.
yeah, solving for S. So
factor out your S and then
the left-hand side is a factor.
divide by.
So you get 1 minus R times S. And on the right-hand side,
You're gonna get, can we just do this, never mind.
on the right-hand side, what can you factor out of the right-hand side?
An
A.
R.
Oh, shit, yeah.
A.
Oh, I mean an A.
And then you're left with a 1 minus r to the n plus 1.
And then you multiply by 1 over 1 minus r.
Yep. So then you multiply by 1 over 1 minus r. And so you get the sum of your finite series is a times 1 minus r to the n plus 1 all over 1 minus r.
Wow.
Damn, could you like, no, you didn't.
Okay, cool.
I just so want to take that 1 minus r out right now.
Yeah, and you super want to like cancel a 1 and a minus
I mean, I
r
know
and be
what I
left
can
with an r to
do.
the n,
That would be
but
cool.
you can't.
No, but like, you could like take the exponent.
But no, but like you can't.
But no, but like, I wish I could make math work like that, but no.
I know, you really itch to try to get something to cancel there, but you can't. So leave it here. And oftentimes this is called SN to denote that this is the finite version. You guys cool with that? It should be, with this one, noted that it doesn't matter what R is. Right, you can get away with R is 2 for this one. Okay, see why? Before it mattered because R had to be smaller than 1 because I was going to add up an infinite number of things, right? But here, who cares? You only have finitely many things. And I would recommend that you put this for the form of this thing down with the finite one because you're going to have to figure a little bit of stuff out. Let's call this. It is entirely possible that this is tweaked plus or minus an r from the formula like this in the book. Right? Because lots of books do this a little bit differently. You guys see what I mean? Like they'll formulate their Sn as going up to n minus 1 instead of 1 going up to n, so that they have an n here instead of an n plus 1. So keep in mind this formula is always up for a little rearrangement, but the basic idea works every time. If you don't want to memorize this formula, you can just remember the idea and then you won't get them wrong by maybe 1 term. Guys cool with that?
Yeah.
Like when I teach this to the finite math class that uses this a whole bunch for accounting type stuff, I really spend more time talking about this trick and I never write the formula down because I don't want them to screw it up. Cool.